The next concept in this chapter is principle of buoyancy. This is also called the Bionic force. This force has given the explanation to the Archimedes principle also. So before going to see the Archimedes principle, so what is its nature we will going to discuss. So what is the principle of buoyancy and bionic force? Let us take a container, try to fill with a liquid or a fluid. Whenever this container is filled up to a certain height with a fluid, try to immerse a body of finite dimensions, and that to be in a form of cylinder in vertical position like this. So a cylindrical body was immersed in this fluid in vertical positions. We know that this is the top surface A, the part which is under the fluid is the bottom surface B. So when we see this situation, the bottom surface of this body experiences more pressure than the top surface. Bottom surface of the body experiences more pressure than the top surface. The only reason behind this property is pressure is directly proportional to the depth. So as much as depth we are going, there the pressure is going to increase. We know that the equation P is equal to rho GH, where rho is density of the liquid, it is constant from top to bottom, where G is equal to acceleration due to gravity, it is also constant which is acting on the fluid, but H is variable. So according to the desired position of the depth, with respect to that position, the pressure is going to change. So let us suppose this is the top surface A. On the top surface A, the pressure is equal to, we can write F1A. Top surface pressure P1 is equal to rho G D1, let us suppose, where D1 is the depth. D1 is equal to depth. At the same time, the pressure at bottom surface is let us say it is P2, that is equal to rho G D2. In place of H, we have written D1 and D2. In place of P1 and P2, we can write PA and PB also. That means pressure at A and pressure at B. Now, we know that F is equal to pressure into area, such like that the force experienced by the top surface is equal to pressure at a top surface into area. So F1, force experienced by the top surface, that is equal to F1 is equal to P1 into A. So therefore F1 we can write that P1 is rho G D1 into A. Similarly, F2 is equal to rho G D2 into A. Now we will find out the difference between the forces at bottom and to the top end. Now we are going to derive the bionic force or buoyant force. Or buoyant force. The bionic force or buoyant force is nothing but the difference between the forces at top end to the bottom end. Therefore, Fb is equal to F2 minus F1, where F2 is equal to rho g d2a minus F1 is equal to rho g d1a. So we can take rho g a as common into d2 minus d1. Depth part d2 and depth part d1. This d2 minus d1 is nothing but the height of the cylindrical object. So therefore it is rho g a h is equal to Fb. Area into height is nothing but the volume of the body. Therefore it is rho gv is equal to Fb, where rho is equal to density of water, g is equal to acceleration due to gravity, where v is equal to volume. So from rho and v, rho into v, in the formula it is rho into g into v. So density into volume of the body is nothing but the mass. Therefore Fb is equal to rho vg, it is nothing but mg is equal to Fb. What is this mg? This mg is nothing but the weight acting on the body. So the bionic force or buoyant force is defined as the amount of bionic force acting on a surface of body is equal to the weight of the water displaced. So the buoyant force which is acting on the body is equal to the weight of the water displaced in the container. So bionic force is equal to the weight of the body. So weight of the body and bionic force both should be balanced. Then only we can expect the density or non-density of the bodies.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.